Hi everyone, Ngaroya here and welcome to another video. In this video we're going to do some exploratory data analysis on World Cup's finals data. So what we're going to do is just scrape the World Cup finals data, clean the data and do some exploratory data analysis on it, where we'll look at the venue and country that has hosted the most World Cup finals, check on the percentage of the finals that have gone into extra time and penalties, then look at the countries that have won the most and the countries that have been the runners up the most. Great, let's jump to the Jupyter notebook and start writing this code. Remember, this code is actually very simple, very easy, can be done by a beginner, and let's just follow along because it's a very easy thing to do. The first thing we need to do is make sure you do install the appropriate packages, which is HTML5 lib and beautiful soup. If you are using the regular, if you use the regular installation to install your Python, you'll just use pip install, and if you use the other or the Anaconda distribution, you just use Anaconda prompt, and you'll use conda install. We'll do conda install HTML5 lib, and after installing this, you'll make sure you also install beautiful soup 4. Make sure you do both of them, and when you install them, they'll just install. Mine they already did, so no need to keep on that. If you used another method to install, which is not Anaconda, you'll just do pip install on the command prompt. Great. The first thing we need to do is you need to import pandas, because pandas is what we'll use to do the analysis, and we also need to import numpy, so that if we need to do any mathematical thing, we'll use numpy. Run this, and what we need to find, I already did, but let's just follow that. We need to find the lists of World Cup finals on Wikipedia. And this list of World Cup finals on Wikipedia, you'll find a list that looks like this, and this is the list that we'll use. Great, so make sure you just copy this link, copy it, and we'll use so we'll define a variable here, call it df, which will hold our data frame. Before we do that, let's first use the pd.read, because there's something you need to see here, and we'll read the HTML, and we'll have that link inside there. When we run this, it will give us a lot of information here. You'll see there are so many tables here. So if we define a variable like df equals to that and run this and look at type for df, you'll find that it is actually a list, because it contains a list of data frames, and that's how the read HTML of pandas works. So if you come to the data frame and index 0, you'll find a data frame there, index 1, you'll find a data frame there, index 2. So you'll have to iterate through all this list to find the data frame that you're looking for, which is this one. Great, so this is the data frame we're looking for, which has the year, winners, scores, runners up, venue, location, attendance, and the referee. Great. The first thing we need to do is make sure our data frame is now this. So df equals that, and then when you look at data frame.head, we'll see this is our data frame. Great. If you look at data frame.tail, you'll realize that these from index 22 going onwards, this is not information that is that helpful for us. From 22 going downwards, not information that is that helpful to us. We'll just have to remove that. And also the referee information, as you can see, they were all links when you look here. So this is not information that we're going to use today. So let's first of all drop the referee column. So df equals to df.drop, and what we want to drop is the referee, and it's written refs. So drop the refs, and we have to say axis is equals to 0, equals to 1, because we want to drop on the column basis. If we don't have this, it will not work. So run that, and we also want our data frame to be equal to data frame. The reason we are doing this is so that the effect is permanent. If we don't have this, it will not be in place, so we have to redefine the data frame again. So the data frame now, we want it to be up to 21, but not including it. So up to 21, and you remember, if you have this will not include that. Run that, and when you look now at our data frame .tail, you realize it has gotten to the last World Cup that was played, and there is no referee column. Great. I think that's all the cleaning bit will do, and because we're just doing simple analysis here, and let's jump straight to our first thing. Let's look at the venue that has the most, that has had more than one, or the venue that has hosted the most World Cups. To do that, we'll just look at the venue, and the venue itself, we want to do value counts. If you do value counts, you'll see that the Olympiad Stadion and Estadio Azteca are the ones that have hosted the most World Cups, with 2 being both of them. For us to find out where they actually are, we can just do data frame, look at the data frame where the venue equals to something like this. Copy, and then that. This will give us a boolean, and it will give us, if you just come now and have square brackets and write df outside there, it will give us that's a small data frame that has this. But because we just want to look at the countries, we'll just look at location. When you run this, it will see the Olympia Stadion is in Munich, or in Germany. This is when it was called West Germany. This is a very long time ago, but this is more recent. Great. But for us to, let's just get rid of this first. For us to do have another condition where is Estadio Azteca, we'll have to have this inside a bracket, and then use the or, and then have this same thing here. Replace this is this, paste it here, run this. There's a problem. Okay, I haven't added this. Run this, and you can see that. However, if we wanted to add another country, another stadium, or another venue here, it will have us do the same thing. That's why it is way easier to use the is-in, something called is-in, to help you with this. And how this works is just have .is-in, this method call, and this .is-in. .is-in inside here, we'll just have a list of the things that we want to see if they're in there. So we'll have the list of this, and the other one, Estadio Azteca. And when we run this, there's like a problem. No problem. You can add another parenthesis, because this parenthesis does not have a partner. Let's just get rid of this and run this. You can see the locations are, it's Germany and Mexico. So this we can just have location here, and you can see it's they were in Germany and Mexico. So Mexico, this stadium in Mexico and this stadium in Germany and this stadium in Mexico have hosted multiple World Cups finals, multiple World Cup finals. Great. Now what you can do, you can just check on how many countries have hosted more than one World Cup. For us to do this, we can do value counts, and I will just do the value counts on the venue and not venue, location. And when you do value counts here, you realize something. We realize that a country like France has hosted it more than once because it is here in Paris and it's also in Saint Denis. And what we want to do is just remain with this final part here: Mexico, Italy, Uruguay, and we see they have been separated by a comma. So this is what we'll use as a delimiter. First thing we need to do is let's create a list. So for us to do this, we'll use list comprehension, and we'll have area. The area, now we want to split it. This area is the variable name that we'll use. So we want to split this, and this split will happen on the comma. It will happen on the comma, and we want to take the last value, so we'll take -1. Perfect. And now this will happen for area in now our location column. What does this mean? When you run this, there's a problem here. Area dot split, there's a problem here. So we want the split to happen on the comma like that. Now you can see it has taken the countries. The problem with this was actually hosted in Brazil, index 3. This index 3 here, let's just go up. This index 3 here, it was hosted in Brazil. The problem is there was no specific World Cup finals, hence meaning the venue of the finals and the location of the finals and the attendance was not there, because what happened is that there were 4 matches that were played. Let's just look at that. If you look here, you'll see there was no official World Cup finals match in 1950. The tournament winner was decided by a final round robin group contested by 4 teams, coincidentally one of the last 2 matches of the tournament, etc, etc. So there was no specific finals. So yeah, that's why you can find that there. But we can continue here, and using this list that has been created, we can now form a Pandas series from this list. This Pandas series is what we will use to add, because what we want to add another column here, and that column will be called country, and it will take those countries. So for us to do that, we need first of all to convert this to a Pandas series. So pd.series, you can do this separately if it's a problem for you, but you can do it together. Just put it in one line, because if you have a equals to this list, and then what you can do to this list is now make this list a Pandas series dot series, and then it will take a, and when you run this, you'll see this Pandas series. And then what we want is, we want our data frame now to equal to now this data frame, and use the assign method. And what we want to assign now is this series. Okay, what we can do, rather than doing that, let's just cut this. We can add extra steps, make this Pandas series, call it b equals to that, and then we'll assign b here, but we want it to be called countries. Country. So country will be equal to that. So this will be what is happening here. We've converted this to a series. We've converted it to a list with all the countries, and then converted that list to a Pandas series, and after that we have assigned that Pandas series and given it the name country on our data frame that we had. Run this, and then when we come and look at data frame.head now, you will see a country column has been added here. However, you don't have to keep on splitting this. You don't have to keep on splitting that. I think I've made a mistake because I think perfect, it's still okay. You don't have to keep on doing that. What you can do is just put all of this inside the same line. So what you can have is just have this list that has been created being converted to a Pandas series directly, and then after that we can just say df, our data frame is now our data frame.assign, and then what we want to assign now is this, and we want it to be let's just add another parenthesis here, and what we want this to be assigned as, we want it to be the country. So country equals to that, and avoid all these steps and just make this one line of code. So if you run this and run this, this will still work. So that you can see it works, we can say countries here and run this, and run this, you can see now another one has been created here, countries. So let's just remain with the countries. Let's just write country here, and let's just drop that df to drop, and what we want to drop is the countries. Sorry, is the countries, and the axis is 0, axis equals 1. Run this. Okay, no comma here, and it has dropped that, and we need to set df equals to that so that it drops it from our data frame. Great. Now after doing this, now we need to find out which country has hosted the most World Cups. You can have now use the new one that we have created, the country, and have value counts here, dot value counts, and when we run this, you can see France 2, Mexico 2, Italy 2. The problem we have here is that Brazil also had 2, but you remember this was had a problem here, and also Germany has 2, but it has split between Germany and West Germany. But using this, you can just do it real quickly. I will not dwell on changing this to Brazil and changing West Germany to Germany, but that's the way it is. Great. Now let's look at, let's just have df.head here, and what we want to look at is extra times. So AET basically means extra time, and then let's just put it 10 here, and when we have AET, all of them are penalties, are extra time. And if we have something like pen, I hope I'll get to pen. Let's just have 20. Run this, and there's a place where you'll see pen. This is extra time that got to penalties, But if it's AET, it means it never got to penalties. As you can see, the score is ended in 3-1. Perfect. So what we want to do now is find out what are the percentage of the teams that went, what are the percentage of the games that went to extra time. And we will do that by first of all finding out how many teams went to penalties, how many teams went to extra time, then dividing it with the total times 100. And we'll find out how many teams went to penalties. Let's first of all create that data frame. So we want the data frame where the scores, these scores, we'll use the apply, and then we'll use the lambda. We create a simple lambda function here. We want where these scores had AET in them. So we'll use x where where a.e.t is in x. And when we run this, there's a problem here. And our simple problem, I've put it outside the bracket, so it's not being identified as a lambda function. Run this, and now we can see where all the AETs are. You can see, oh, extra time, extra time, extra time, this extra time that ended in penalties, extra time, extra time. Great. Now what we want is to find out how many they are, and I will just do that simply by using len. So if you have length of that, you'll see there are 7. And what we want to do with this is, let's comment it out. We want it to be divided by the whole length of the data frame. So if you have length of the data frame, you can see it's 21. And now we want to take this. Let's do that. Then divide whatever we had with the whole length, multiply by 100. And this now will give us the percentage of the matches that ended in penalties, that reached extra time. Of all the matches, that 3% of the World Cup matches reach extra time. Of that 3% of the World Cup finals matches reach extra time. And I think that's a very big number, because it means 1 in every 2 gets to 1 in every 3 get to extra time. And we can just use np.round to round, and then we can just have all of this inside another bracket, and we can just have 2 decimal places, and meaning 33.33, meaning 1 in every 3 World Cup finals matches go to penalties, go to extra time. Now let's see, of these matches, how many of them, of the extra time matches, how many of them, or which percentage of them go to penalties. We'll use the same concept here. Let's just take this, and what we want now is this same thing here. Is this exact same thing here. Let's just have all of this. Copy that. What we want now is all of this, but now this will be replaced with the same thing. I just don't want to keep on redoing the code itself. It will be replaced by this, and now one of them will be pen. So this will replace it with pen, because as we see here, the ones that go to penalties have a pen written in them, PEN. Okay, there's a PEN in them, PEN, exactly. So we'll use the same concept here, but differently. I think I made a mistake. Let me just see. Unsupported types for integer and string. Let me just check on where the error might be. Okay, I understand the problem is because it is checking on length here, and then it's dividing it with a sort of a data frame. So it's supposed to have length also here, and finish this off. Okay, with that, run this, and something else we need to add here is multiplied by 100, and we can see 28% of those matches go to penalties. So meaning 28% of all the matches that go to extra time go to penalties. Great. What we can do is just do the same thing we did with the other ones, and have this inside that, and np.round. This is not necessary, but I'm just so making sure that it does not look so heavy. Close that off, and have 2 decimal places here. Great. Something else we need to do is just check on the attendance. Let's just check on the attendance, and see what's the average attendance of the World Cup finals. What you could do is just def attendance and then use .mean. But when you do this, you realize that it will not work because we are trying to find the mean of a couple of things here. There's to numeric. We need to could not convert some things to numeric like this, and this is because this is not a numerical value. We might replace it with the average, or because there was no specific World Cup finals that year, and we can just drop it, and that's what we'll do. So what we'll do is just come use .drop, and what we want to drop is index 3, this index here, and we'll just drop index 3, write 3 inside here, and then when we run this, now we can see it jumps index 3, it goes to 2 to 4, and then what we want to do is find the mean. Run this, and there's a problem because this is extremely large. What I'll do, I'll just take this and make sure I call it before checking on that. Run this. It's still very large. The problem mainly is because if we look at info, we'll find that the attendance is an object, and that's giving it some problems. So what we can do here, let's just get rid of this. What we can do here is we can have use the .as type, and then we want the type to be integer. Run this, and now it gives us a sensible value. I don't think we had a problem with this being here. Let's just see. It still brings out the same answer. So that was not where the error was. So we can see 76,266. That's the average or the mean of the number of people who have attended World Cup finals. Now let's just look at runners-up. Let's look at the countries that have been most disadvantaged in the World Cup, who have been runners-up the most amount of times. Let's just look at df runners-up, and then let's have value counts. And straight away we can see Argentina, West Germany, Netherlands, and we can also see Germany here again, meaning Germany is actually 4. Great, and let's now see who has won the most World Cup finals. And we can just see here, we want to look at winners, and we can see Brazil is at 5, Italy is at 4, West Germany and Germany, there's another Germany here, so Germany is at 4, then Uruguay, Argentina, etc. You can see West Germany has been the most unlucky, but has also been very lucky. Germany has gone to 8 World Cup finals, and Brazil and won 4, lost 4. That's great, and that's all we had, just to do some exploratory data analysis on the World Cup data, just as the World Cup is about to start. Thank you very much for watching this. Make sure you throw in a like and subscribe. See you in the next video.